Good day, sir. Good day, everyone. I'm Cadet Sala Spencer, and I'm going to teach you how to do the manual plotting in Nav 2 to 5. So first thing and foremost, I don't know how to do the overall procedure of the plotting, but by the help of my classmate, they give me how to do, or they give me the tips or steps on how to do the manual plotting. So that's why I'm going to teach you the proper manual plotting and the tips for this one. So first thing to do is you need to observe or observe the observation that was given by your advisor, which is the two targets. If ever they given to you the two targets, then you will plot the first observation by using the small r, mark it at the small r. Then the second observation is mark it with a small m. The next one is for the relative plot. The RML, DRM, SRM, BCPA, DCPA, TCPA, relative motion line, RML. You need to draw a line or connect the first observation and the second observation, which is the small r and small m. Connect it, the first and second observation, and extend it until either crosses or pass at the center of the compass and mark it RML. So the reason why you need to extend the relative motion line is for you to determine the closest point of approach, which is the CPA, and the direction relative motion, which is the DRM. And if the RML crosses at the center of a PPI, then just extend the RML to the graduation of the compass for the DRM. If the RML passes either side of the center of the compass. Next thing to do is you need to transfer the RML, which is the line was origin from the R. You need to transfer to the center, going toward transfer the RML line to the center, and always remember the origin of the measurement is from R, then going towards M, which is the speed related motion. Then measure the distance from R to M using the compass divider. Then bring it to the set distance scale sa radar. So, napto sa kilid ang distance scale. Then imo i-measure using the compass divider. So, these are the useful formulas in radar plotting. So, the formula to get the SRM is distance from R to M times 60 over time interval in minutes. So from the scenario is SRM is equals to 2.0 times 60 over 6 or divided by 6. So the answer would be 20 knots. And bearing to CPA or BCPA, if the RML crosses the center of the compass, the BCPA is the same as the common bearing of the contact. For easy identification, just mark it with an A. Then, if the RML passes either side of the center of the compass, BCPA is equals to DRM plus negative 90 degree. So, you should note this one. If the RML is located counterclockwise from the DRM, then you will use positive. Then, if the RML is located clockwise from the DRM, so you will use negative. So from the scenario, BCPA is equals to NA or 45 degree through distance to CPA. If the RML crosses the center of the compass, the distance of CPA is 0 or collision. So to get the CPA, if the RML passes either side of the compass, just measure the length between the center of the compass and the CPA. So if kuan daw ang pagkuha sa DRM niya kay sa BCPA kay ang DRM if counterclockwise kay positive, if clockwise kay negative, ada nimo og 90 degree or minus nimo og 90 degree. So the next one is how to locate CPA. CPA can be located at the intersection point between the BCPA line and the RML from the scenario. The formula for this one is dCPA is equals to 0 nautical mile or collision since the RML crosses to the center of the compass time to CPA or TCPA. So the formula is TCPA is equals to distance from R to CPA times 60 over SRM. So from the scenario is 10 times 60 SRM ITCPA is equals to 10 times 60 over 20 is equals to 30 minutes. So the next one is target through motion. Transfer the on-ship course line to the position of the R. Then draw a line reciprocal to the course line from the R to locate the E or the on-ship to accurately measure the distance of E from R. So just use the formula distance is equals to on-ship speed times time interval in minutes, time interval over minutes. So from the scenario, distance of E from R is equals to 20 knots times 6 is equals to 2.0 nautical mile. Then measure the calculated distance in the set distance scale. So bring the first of the divider to R and swing the second to create an arc that intersects the transferred course line. The point of the intersection is the position of E, with E, and the target through course or the TTC. How to get this one? Draw a line from E to M, then to determine the accurate course, just transfer the E to the M line to center of the compass. Then target through speed TTS. To calculate the TTS, use the formula. So the formula for this one is TTS is equals to distance from E to M times 60 over time interval in minutes. So from the scenario, 2.0 times 60 is equals to 20 knots. And the next one is for collision avoidance. From the scenario, the on-ship plan to maneuver when the contact is 4 miles with a CPA of 2.0 miles to her point of the execution, the MX. If the distance is the basis for avoidance, just measure the desired distance from the set distance scale. Then bring the first leg of the divider to the center of the compass, and the second leg must swing until it intersects the RML. So the point of intersection is the position of the MX. Then the new RML or NRML, you need to draw a line from the MX tangent to the circle of the new CPA avoidance course or AC. Then transfer the NRML to M. Then draw the line reciprocal to the direction of the RML. Then draw an arc from the R by positioning your compass divider to E and R. The intersection of the arc created during the swinging of the compass divider clockwise and the transfer and RML is the location of R1. So, draw a line from E to R1 for the avoidance course of new course. To have an accurate measurement, drag the E to R1 line to the center of the compass for the avoidance course. Then from the scenario, avoidance course is equals to 0.35 degree through avoidance speed. The same procedure with the avoidance course, but there is no need to create an arc in order to locate the R1. What are you going to do is just locate the intersection point between the E to R line and the transferred NRML. Then measure the length from E to R1, then bring the stretch of the divider to the set distance scale. So use the formula. Avoidance speed is equals to distance from E to R1 times 60 over time interval in minutes. So that's it. So that's it, guys. That's are the pros and tips for doing the manual plotting. Thank you for listening, and I hope you understand. Thank you.